clarification, there's only one of these questions on your test, just one. And I'll tell you exactly what it looks like before we're done. So, this is the law of cosines. I would really recommend that you draw a triangle like this and you write down the 3 versions of the law of cosines somewhere. Otherwise, I'm going to ask you guys to see it and memorize it. Because I'm not going to give it to you the rest of the class period. I'm expecting you to draw that conclusion off of your notes. So while you're writing, I'll kind of be background noise. Notice that the triangle is not a right triangle. This triangle is labeled A, B, and C by its angles. And then using other vocabulary words from the past unit, everything opposite of A, you have capital A for the angle, opposite of A is little a for the side. So there's a huge difference between capital letters that describe angles today and lowercase letters that describe sides today. The capital letter and the lowercase letter will always be opposite of each other. So as you work through the formula, 3 different versions, they're all carbon copies of each other, solving for a different side length. Little a squared is equal to little b squared plus little c squared minus 2 little a, little b, little b, little c cosine. Yes.
Does it matter like what side's A, B, and C?
As long as it's labeled as A is opposite of little a. It does not matter, but those 2 must match. So when I memorize this, I always go through this in my head. What you're solving for, the side you're solving for, that doesn't look good. The side you're solving for and the cosine of the angle are always the same. So if you're solving for A, you're going to take the cosine of angle A. And then these 2 right here are the same as these 2 right here. That kind of makes sense? So if I'm solving for B, I'm going to take the cosine of B. If I'm adding A and C together, A and C are in front of cosine.
I thought cosine was like the one that was adjacent. So how could how are they the same?
So the cosine ratio is adjacent over hypotenuse, right? But I'm not even looking at side lengths. I'm just doing the cosine of the angle. Does that kind of make sense?
Yeah.
So you're used to seeing like cosine of C is adjacent over hypotenuse, but there is no adjacent and a hypotenuse here. It doesn't make any sense. But if this angle is 87, I'm just going to do cosine of 87. All right. So in this scenario, hopefully you'll start to see some patterns of what it will look like. It is a calculator monster. I can't do this in my mind. I do this step by step by step in my calculator. There is an easy version where it's all calculator, and there's a more complicated version that requires student input to solve. All right. So 2 scenarios that might happen, and you can just watch this. Scenario number 1, which is the easier of the 2 scenarios. It gives you a number here, it gives you a number here, and it gives you an angle here. All right, so everything is kind of tied together. So in this scenario, they're going to ask you to solve for little c. That's the only thing that you can solve for is little c, because you have the cosine of c. So that would look like this. C squared equals A squared plus B squared minus 2 AB cosine C. In this scenario, you type all of this madness in your calculator, and it gives you a number. Then the last step is to take the square root and it gives you what c is. That's the easier of the two scenarios. Does that kind of make sense? Now, we can do that for A or B. It kind of, yes ma'am.
How can you know if you're right? Like, how can you check?
The only way to know if your answer makes sense is to apply the triangle inequality theorem. The two small sides add up to be bigger than the long side. That's the only way to make it make sense. The harder of the two scenarios would be something like this.
Oh yes, that's pre-AP.
All of this is pre-AP. The regular kids don't touch this. Okay, now in this scenario, they will probably give you an angle to solve for. They might say, hey, please solve for A. Now they're asking you to solve for A. The only law of cosines that solves for A starts with A squared. So that would be A squared equals B squared plus C squared minus 2B C cosine of A. So now in this scenario, we're solving for A way over here. And we have to do all this mathematical simplification to get to a point where we can take the inverse cosine of A. Those are the only two scenarios that will happen ever in this case. Okay? So I'm going to go through two questions that are what you should expect to see on your assignment today. Then I'll go through two questions that actually apply the whole process of the law of cosines. Here we go. This is the generic introduction to the law of cosines. So student input, right? Here's where you have to figure out which equation you want to use. What are we trying to solve for? Little b. So if you go back to your notes, what is the one that equals little b? Say it. B squared
Equals A squared plus C squared minus 2AC cosine.
Alright. This will be printed on your test. This will be printed on your test. All three versions will be printed on your test. It's your job to figure out which one to use. So I like to say angle A, little a. Angle C, little c. Angle B, little b. That kind of helps me fill out what I'm doing. So what is b squared? Hold on. I'm going to preemptively do this so it can load in the background. So little b is b squared. Little a, little c, minus 2
times 40 cosine angle 87.
So many opportunities to make a mistake. At this point, you are almost done. I require no more student input. I just require accurate meat finger mashing on the machine. Okay? So I think I can remember that. You ready? We're gonna go to our calculator. You have it written down, right? Hopefully. Not yet. Epiphany? No? Okay. So in my calculator, I'm gonna go to a calculator here. I'm gonna do exactly what I had written. 47 squared plus
40 squared.
40 squared. Uh-oh. Minus 2 times 47 times 40 cosine of 87. That's exactly what I have in my paper, right? Let me just trust the machine. Ready?
Do we take the square root?
You have to trust it. 3,612.22. Leave it just like that. Because, we good? So leave it just like that. I'm just going to go back 1 second and write that b squared equals 3,622 12.22. Now the only last step to do is to take the square root of b. So I take the square root of both sides. I really, really, really encourage you guys just to do the square root of the answer. This will take the square root of this number, 60.1. And you're done.
How do you put answer?
Control negative.
Do we round?
60.1. Right? Your assignment says to the nearest 10.
But didn't you do insult and put x squared instead? Because that's what I got.
Where?
I did insult but instead of b squared. And I got
So 60.1. Where am I going? Okay, now, does the answer make sense?
Yeah.
It does. It doesn't, but it kind of does, because 47 plus 40 is 87. Is that bigger than 61? So triangle exists. There's no more Pythagorean theorem where a squared plus b. That's it, guys. That's the whole application of that process. So once you get the formula down and you do 2 steps, boom, there's the answer. Though in previous years, when I had a lot of time, I proved this formula. I went through and I started with a squared plus b squared equals c squared, and I did just a boatload of geometry, and when I got done, this equation popped out. Is that going to help you understand this? No, it's going to freak you out. So I'm just going to here it is. And guys, welcome to the second semester of geometry, or really the 4th 9 weeks, where it is just going to be plug and chug and plug and chug and plug and chug. All right, I'm going to give you just a boatload of formulas and ask you to solve for it. Okay, this is the test question. Now, on the test, it's going to say solve for angle A. Right? Notice there is no angle inside the triangle. It's just a straight up random triangle, and it says solve for angle A. So if I'm solving for angle A, what equation do I want to use? I want to use the a squared equation. A squared so these two should match, and these two should match. It has like that symmetrical reflection in the middle of the equation. It goes ABC, BCA. Okay, so let's just make sure we keep all of our ducks in a row. This is little a, this is little b, and this is little c. A very common mistake where you get your little letters mixed up. So let's write it out. Little a is 22 squared equals I love this equation. So I'm not gonna, no. You cannot just type this in your calculator. So here's something I need you guys just to look at and guess. What would you do if I said there was like 3 things you must do before you start solving? There's 3 things you can simplify. What are those 3 things? And it's 3 separate steps. Go ahead.
Combine like terms.
Not yet. So step 1 right here, simplify that. Okay. Step 2 right here, simplify that. And step 3 right here, simplify that. So we're going to multiply all the numbers together and not use anything cosine. So do 3 separate steps. It's going to give you 3 massive numbers, and you need to work with those numbers. Is this going to bother anybody if I do this? Like if I scroll up my work here? Does that bother you, Zeke? Okay, so 22 squared. Here's how I do it. 22 squared, 484. I go back to my work and I say this is 484. I'm going to simplify these two. 26 squared plus 15 squared. 26 squared plus 15 squared. 901. Minus 2 times 26 times 15. 780. Okay, so small break. Were you able to follow that process?
Yeah.
You okay with that? Yes, sir.
So like, what do you know? Like, how do you know if you need to simplify it?
So in the first scenario where it was we're solving for a side length, that's just calculated. Alright, in the second scenario we're solving for an angle, this is where we have to do all the simplification processes. Alright? Now, student input, this is algebra. This is algebra with just a little bit of a trigonometric function in there. So what do you do next if you have number minus nonsense? Yes, sir.
You subtract them from each other.
Subtract which one? What is our ultimate goal here? Let me take a step back now. Our ultimate goal is to isolate the cosine of A. So to isolate cosine of A, I need to subtract 901 from both sides. So 484 minus 901. Negative 417. Let me write that down here.
No, you did something wrong.
You did what?
You have 26 squared plus 13 squared. Go back to the calculator, please.
Oh, is it supposed to be?
You did 15 squared.
Is it supposed to be 15?
It's supposed to be 13.
It is 13.
It's 15.
You
just wrote 15. Yeah, you
I wrote 15, but it looks like a 13. Sorry, my bad. Thank you for clarifying that.
You couldn't just take 901 and subtract it from 780.
No,
No.
because
that's
this is like saying 2 minus 3x.
Oh, okay.
Can you just take 2 and subtract 3x from it?
So like 2 different things.
And they're 2 different things. So generally you'll get a negative number here. And now I have negative 780 cosine A. It's negative 780 times multiplied by cosine of A. So how do I undo multiplication? You divide by negative 780. So let's do that. Negative 417 divided by negative 780. Oh. So remember the trick here? Negative 417 divided by negative .780. If you want a decimal back, you can put a decimal. I don't know which one's nicer.
Neither just do control enter.
Yeah.
Either way, this is what we're looking at. 0.034615. And it's a positive number. .053461. Oh, what is it? 0.54.
3, 4.
Four, five?
1, 5.
Okay, now he goes back to what we were doing yesterday. You're solving for an angle. So this guy is going to move to the other side of the equation and become the inverse of cosine for now it's okay because our calculator, we can just do trig inverse cosine, and then we can use the answer the calculator spit out, but we don't have to round anything. Hey, 57, 58 degrees. We'll round to the nearest degree. Or 57. Let's just do 58. 58 degrees. Is that okay? So all of that work to figure out that angle A equals 58 degrees. Damn. That's the test question. One of them. So just remember the process, okay? Write down the equation you're going to use. Simplify the three parts. You subtract the whole number. Divide by the number in front of cosine. And then take the inverse cosine of your answer. Yeah. Good thing it's on YouTube forever now. Okay, one question like that. Now, this is not pre-AP. This is not the application of this. This is just introducing you guys to it. So I have two more questions and I'm done, right? I'm just kind of slowly running out of time here, but I think we're having a good process. So, note the instructions. Use the law of cosines to solve the triangle. When it says solve the triangle, what is it implying?
All of it.
Find everything that's missing. The one missing side length and the two missing angles. So I'm going to speed through this. You can watch or you can copy. It is up to you. I want to show you the whole process. So to solve for b squared is equal to a squared plus c squared minus 2ac. Cosine of 88. In this scenario, everything on the right side of the equation has a value. So I can type that in my calculator. 45, 43, and 88. A squared plus b squared minus 2 times a times c cosine of 88. That's the whole right side of the equation. Enter. 3,783.94. Find the square root of that number. 61.1. 61.1. That's little b. 61.1. Now what? Now I can angles or angle. As soon as I solve for one angle, I know two angles of a triangle, and I can do the third angle theorem. 180 minus the two angles that I have gives me the leftover angle. So that saves me from doing a boatload of trigonometry. So if I have 61, this is student decision. You can pick A or C. A, we want to solve for A. That's going to be A squared equals B squared plus C squared. This is a 43 this time. A squared equals B squared plus C squared minus 2 B C cosine A. So step by step, 45 squared, 2025. 61.1 squared plus 43 squared. 43 squared. 5,582.21. 5,582.21 minus 2 times 61 times 43. 5,254.6. So beautiful. Right? This is just simplifying all these terms. Step 1, step 2, and step 3.
So you just take 550.
2025. So in this scenario, I'm going to do minus 5,582.21 on both sides. $20.25 minus 5,582.21. I'm going to take that number and divide it by the term in front of cosine. So divided by 5,254.6. Oh, it should have been negative. Forgot my negative. It should be divided by negative 5,254.6. Then I'm going to take the inverse cosine. The inverse cosine of that answer. 47 degrees. So all of that math to say that A is 47 degrees. Then you still have to solve for angle C. So I subtracted 5,587.21. I got a nasty decimal. Then I divided by this. That gave me my other nasty decimal. So once you get to that last angle, you have 180 degrees in a triangle, minus 88 degrees spoken for, minus 47 degrees that are spoken for. It leaves you with the last angle is 45 degrees. So all three of those angles add up to 180. The solving method.
I wish the people of YouTube could see your soulless smile.
Yeah, it's just,
Well, now they know.
it's great. It's not hard, it's just a lot of math. So, on your assignment today, you will see questions like this, where it just solve for B. That's all I'm asking you to do on your assignment today, right? And I know you're like, whew, thank God, thank the baby Jesus, but, on your test, it looks like this, where you're having to solve for the angle. Okay? So on your homework, apply it, solve for the side length. On your test, hey, I tricked you, solve for the angle. Okay? So let's run through this last one. Let's just set it up together real quick. We already did that one.
Yeah.
It's too easy. That's all I have. How about this? Solve for that angle x. Let's set that one up and we'll be done. Huh? What are we trying to solve for? C. So little c equals oh wait, I have to give you an angle here, don't I? 2 Wouldn't it be amazing if I guessed that was actually 68 degrees and it came back to 16? Would it be weird? Should we try it? Alright, 23, 27, and 68. 23 squared plus 27 squared minus 2 times 23 times 27 cosine of 68. And take the square root of that answer. 28. I know, because I just created it.
That'd been funny if it was.
I wonder what angle would have made it 16. How do I copy that? We can cut it in half and see what happens. 34. Nah, I'm feeling 37.
Imagine that.
Bam, good. So if it's 37 degrees, would have made it 16. Man, that feels good. I feel really good about that. So that's pretty much it. I know it's a monster. We're gonna have time next week to look at it again still.